Okay, today we're going to look at the empirical formula. What is an empirical formula? Simplest form. So we have the smallest ratio of subscripts in the formula. So we are going to use our percent composition, which we learned yesterday, to find the empirical formula. Because in the laboratory, a lot of times it's easier to find the percent composition of a compound and then work backwards to find the empirical formula. So if we want to, in the experiment, the combustion of 11.5 grams of ethanol produced 22.0 grams of carbon dioxide and 13.5 grams of hydrogen. Calculate the empirical formula of ethanol. Let's do one. Is that one in your notes? Yeah. Okay. We should do one. Well, okay. Ethanol, it's carbon, oxygen, and hydrogen, and combustion. Let's do one that's simpler first. Let's do this ascorbic acid one first. It was before. Go in front. Because we skipped it yesterday. We skipped this problem yesterday. So ascorbic acid, which is vitamin C, cures scurvy. You guys know what scurvy is? Lack of vitamin C. The sailors used to get it a lot when they had to ride in boats across the Atlantic to get over here, because they usually ate preserved meats and canned stuff, they didn't have a lot of fresh fruit, and the fruit would grow rancid and moldy before they were able to get new supplies. So they didn't have a lot of vitamin C in their diet, and they would get scurvy, which means they'd have a lot of skin lesions, and their teeth would go bad and fall out, and their hair would start to fall out. That's all part of scurvy. Okay, and so they found that if you had added vitamin C to your diet and had more fresh fruits and stuff in your diet, it would prevent scurvy. So that's a little fun fact for you. Scurvy is a popular word just for talking about something that's kind of gross, right? That's where it comes from. So vitamin C is composed of 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen by mass. So we're going to determine the empirical formula. So the first step, and there's the little box, but I'm just going to talk through the steps. First step, what color of ink should I use? Green? Pink. Give me the percentages against the, what was it? 40.92%. First thing we want to do is convert these into mass. And when they give us percentages, we're going to just assume we have 100 grams of this, 100 grams of the substance. So if 40.92% of 100 grams is carbon, how many grams of carbon are there? 40.92, right. And hydrogen would be 4.58 grams. And 54.50. Okay, next step. We need to change these to moles. So we're going to divide by the molar mass. So for carbon, that is 12.01. Hydrogen, oxygen is 16. Everyone know how I got those numbers? Okay. So if someone would do those calculations for me. Which one? 4.53?
That's the bottom.
Okay. Oops, it went to 0. Can you get your answer back? It was 3 point something. 3.41. And the first one? Okay, so we're in moles, and what we, well, and on the last worksheet we did, the stoichiometry worksheet, remember we said we can say in 1 mole of compound there were 8 moles of hydrogen, so it was really a mole ratio. So you have 8 moles of hydrogen with, was it 3 moles of carbon, and I don't know what the other number for oxygen was. But they were mole ratios. You can make a mole ratio. So to make a mole ratio, we need to divide by, and it's going to be easier to divide by the smallest number. So we're going to divide by the smallest number of moles of these 3. This is 3.41. So moles cancel out. So if the first one we get 1, last one we get 1, what's that middle one? Okay, 1.33. So these would be our mole ratios, and these would be our subscripts. Can we have 1.33 as a subscript? No. And if it's like 1.0 something, we can round to 0. If it's 1.99, whatever, we could round up to 2. But 1.3 isn't very, it's not close enough to just round. We're going to have to multiply by a number to get, multiply by a whole number in order to get closer to a whole number. So what number would we multiply by? So if we multiply this number by 3, what do you get? 3.999, something like that. So basically it's 4, close enough to 4 that we can round. But since we multiplied this one by 3, we have to multiply all of them by 3. Now this will be our subscript. So our formula is going to be C3H4O3. There we go. Does everyone understand those steps? So there's really not an equation that we follow. It's just a series of steps that a process that you go through. You basically want to find moles and then find a mole ratio between the elements. Okay, what is another one that we can do? Sample of a compound contains 1.52 grams of nitrogen and 3.47 grams of oxygen. The molar mass of this compound is between 90 and 95. So we're going to do an extra step at the end for this one. We're going to determine the molecular formula and the accurate molar mass of this compound. What I like to do, and I don't know that your book does this, but I like to get these into percentages first. So you would take 1.52 divided by the total. Which would be what? I'm curious. The total mass. 1.52 plus whatever the other mass was. That's what it, no, we probably shouldn't round yet. Is the total. So for nitrogen, it was 1.52 divided by 4.99. 30. $30.46. Let's just do that. We don't want to round very much right now. Okay? Until we get to the end. And that is going to be percent nitrogen, which is equal to grams. And that was nitrogen, right? Not oxygen. How much oxygen was there? Okay. So that would be 69.54. Okay. What was our next step? Convert to moles. Mass of nitrogen is 14.01. What was the top one? 2.17. And oxygen? I'm going to just write a couple numbers here because I'm going to try it without doing the percent. I just want to know what you would get. I usually change it to percentages first. Okay, so then what would be our next step? Find a mole ratio by dividing by the smallest one. So that would be 2.17. Ignore my numbers that I wrote up there. .001. So we're close enough that we can round to 2. So what would be our empirical formula? NO2. Right. We don't have to show the 1. It's fine, but you won't ever see that. Okay. So even if we wouldn't have changed it to percent, you would, because it kind of makes sense that it's a ratio. When you get into mole, you divide by 0.108, and you get 2 to 1 also. So we really did an extra step. Oops. So you can do it either way. Now, the next step, that's where we'd stop for empirical formula, but the question is asking for its molecular formula. It says that its molecular mass is between 90 to 95 grams, right? That's what it tells you? Is that the right mass, 90 to 95? Okay, so it says it's between 90 and 95. What we need to do is compare this empirical mass. So what would the mass be if we used just the empirical formula? It'd be 14.02 plus 32. So 40. Is that between 90 and 95?
No.
No. So our molecular mass is not NO2. This is our empirical, or our molecular formula is not NO2. Empirical formula is NO2. What would our molecular formula need to be? We have to multiply this by 2 to get it between 90 and 95, right? So we have to multiply all the subscripts by 2. So it'd be N2O4, in this case, would be our. Where did you get lost? They told us that the molecular mass is between 90 and 95. So when you add up the mass of NO2, you get 46.02, which is not. So since you have to multiply this by 2 to get between 90 and 95, you multiply the... Oh, and the accurate mass? So then, okay, so this would be the first part. This is our molecular formula. You would need to add this mass up, the N2O4. So what is that mass? So 14.01 times 2 plus 4 times 16. 93.04 grams per mole. 16.
92 or 93? 92. It's 92.
Why is oxygen 16 and
Basically, it's 92.
92.04? Okay, now let's go back to that one problem. It's going to be a little difficult. Okay, ethanol. Ethanol has carbon, hydrogen, and oxygen in it. And it says it's combusted. Do you guys know what combustion means? What is a fire? It burns. But what do you have to add to it to get it to burn? Oxygen. So you would have ethanol plus O2 would give you, we got carbon dioxide plus H2O. Now we can't balance this because we don't know the formula for ethanol, but we do know how much carbon dioxide and how much hydrogen there was. So what we're going to do, we need to figure out. Now, does that make sense to you? We only had 11.5 grams of ethanol and 22 grams of it. We got 22 plus 13 grams of product.
Yeah.
Why does that make sense? But how did we get more mass than what we started with ethanol?
The chemical reaction gain weight.
You can just gain mass?
People gain mass.
What? Right, we added oxygen, so we added mass right here. So this is where our extra mass comes from, is oxygen. So we need to figure out, I'm going to just write C, H, and O, because we know there's those three elements here. We don't know how much of each. Where did all this carbon come from, though? It came from the carbon here. Where did all the hydrogen come from? Ethanol. So if we can figure out how much carbon and hydrogen are here, we could then calculate how much oxygen is in ethanol. So how much carbon is in carbon dioxide? 22 grams of carbon dioxide. This is probably one of the more difficult ones that you'll see. More steps to get to our beginning part where we've started. Yes. Yes, Michael. Huh? Oh, but it's not balanced. Like if this was C2 something, then we might need a 2 here. Like it's not balanced because we don't know that formula. It'd be nice if we could do that. It would be simpler. What we need to do is convert carbon dioxide, grams of carbon dioxide into moles of carbon dioxide. So the mass of carbon dioxide is 44.01. Now how many moles of carbon are in one carbon dioxide? So one CO2, whoops, I should probably put 1 mole of CO2, right? CO2 has how many moles of carbon? 1 mole of carbon. But what? Does everyone see how? That canceled. We need to cancel this out. We're trying to find the mass of just carbon in the 22 grams. I'm going to show you 2 different ways to do this. You can choose which way you guys like better. Yes? Yes? Sure. Now we'll change moles of carbon into grams of carbon. So 1 mole of carbon is 12.01 grams. So that would give us the grams of carbon. So how many grams is that? Someone calculate that. Should be under 22. There we go. Let's try this a different way just to show 2 different ways, and then we can as a class decide which way you like better. We could find the percent composition of carbon and carbon dioxide. So do you remember how to find percent composition? It's 12.01. You take the mass of the element over the total mass, which we already said was 0.01, times 100. So what percentage is that? You remember how to do that from yesterday? Okay, 27.3% carbon. So 23% of this 22 grams is carbon. So how do we find how much carbon would be in the 22 grams? Yep, take 0.273 times.
That's not right.
Do we get the same number? We should get the same number. What's not right? So if you take 23% of the 22.0 grams, you got 6.0 grams. So either way, which way do you guys like better? The second one? You like the second one? Yes. Carbon's mass plus 2 oxygen's mass. Percent. So then 27.3% of the 22 grams here. So you take 0.273 times 22 gave you 6.
So you just your carbon divided by your mole.
Mm-hmm. So this is easier. The second way is easier?
Yeah, 6 short time.
Okay. Let's scratch out the top part. We'll do the second way for hydrogen, because now we need to find out how much hydrogen. So let's. I'm going to get a new page. I'm going to lose all my numbers. We found out there's 6.0 grams of carbon. Okay. Now to find hydrogen. In water, we have 2 times 1.01 all over 18.02 is the mass of water. That's one we'll probably use a lot. You'll start to remember 18.02. So what percent of water is hydrogen? 11.2. So 11.2% hydrogen. And how many grams of water did we produce?
13.5.
So 11.2% of 13.5 would give you how many grams of hydrogen? 1.5. Does everyone follow that step?
I have a question. Why didn't we just do it this way the first time?
I didn't think of it.
Or on the-
There's two ways. There's always multiple ways to do everything. Two ways to skin a cat, right?
Yeah. Either way.
Either way, it's going to hurt. So 1.5 grams of hydrogen. I'm going to copy that here and then erase this part. And now, how much oxygen? How would we figure out how much oxygen? Because in our equation, there's two things with oxygen in it. Do we know how much? And we produce, the rest of this is oxygen. There's more oxygen here. There's oxygen here and here.
Well, couldn't we just
Yes, Evan has a...
couldn't we just take the mass that we got from carbon and subtract it from the mass of CO2?
Yeah.
O2 and then divide it by 2.
But we don't know how much O2 we used. What we're going to do... Yes. Mm-hmm. You do 16 on top? Mm-hmm. But we were trying to find out how much hydrogen was it. If you wanted to, yep.
That's the mass of H2O.
So what we're going to do is we know we started with 11.5 grams of ethanol. And we know how much carbon, how much hydrogen. We're going to subtract those from 11.5 and that'll give us how much oxygen. Does that make sense? Okay. Not at all? Did I hear not at all? Okay. So we're going to take 11.5 grams of ethanol minus, we know that 6 grams of it was carbon, minus, we know 1.5 grams of that is hydrogen, and this will give us how much oxygen is in that ethanol. What is it? 4? Okay. Let me erase this and rewrite it. Now we're to the point where we can convert to moles. We still...
This is a little bit of a...
Will there be a problem like this on the test?
The correct answer is no.
Probably not. I would guess not.
Do this.
This is all or nothing.
So, we gotta convert to moles. This is the easy part. Oops. I do agree that second way using percentages was way faster. Okay. Anyone have any of these three?
Carbon is half of the molar. 0.5.
Oxygen is 1/4. Yep. And this one should be close to 1.5. 1.49. No. Now what's our next step? We need a mole ratio.
Smallest.
So we divide by 0.25. This is 1. This is 2. What's this one? 5.96. Pretty close to 6. So our formula, wow, it came out so nice. Oh, there you go. Ethanol. Which ethanol really is, I'll draw what ethanol looks like.
Why do I need to do this when I already know it? Shouldn't we know that anyway?
So that's ethanol. Do we have 6 hydrogens? Yep. Oxygen, 2 carbons. Yep, good. Okay, the worksheet. Let's do Monday. Do Monday. Because your scavenger hunt's due on Friday. Scavenger hunt's due on Friday. We're going to do a lab. I don't want to do over one night. So this will give you time